MashaAllah, Alhamdulillah, Rabbil Alamin. We all have to thank Allah subhanahu wa ta'ala for giving us the ability to conduct another class. We have done this until 6 minutes and then it went off. So I have already drawn, we have already gone that far and then the video, shut up. So I have to come back again to start. So our topic is fractional distillation. Two words, fractional and distillation. Fractional means a part of. I explained in my previous video. Now, distillation means to burn something or boil it, okay, and then the steam goes out, okay? In simple terms. Now, crude oil, we know, is one of the richest sources of revenue for many governments now, especially Saudi Arabia and many Arab countries, okay? The crude oil comes from the decay of fossils, or trees, or some bacteria, millions of years ago. And these fossilize, they decompose, they form what you call crude oil. And people, they drill it. You have heard about oil drills, yeah? Sometimes it's in the sea, sometimes it's on land, okay? They drill inside and get out this thick crude substance, and they put it in barrels, and they sip it. Sometimes they refine it in the very places. Sometimes they have to carry it to some places, depending on technology, okay? Some countries, they don't have the technology, okay, to drill the oil and to refine it. So some companies have to come and drill it and refine it. Like in Africa, in many African countries, we have the oil, we don't have the technology to refine it. So you people, that's why I'm teaching you this, you people to become chemists, biochemists and so forth, okay, oil engineers and so forth, to help us drill our own oil and distill it. We get all the money. Because what happens in Africa is the company that come to drill the oil are commercial companies, private companies. They come and drill the oil, they refine it. If the revenue is 100 pounds, they give 20 pounds to African governments, 80 pounds go to their coffers. So our oil, we don't get the amount of money we're supposed to get. That's why Africa remains poor, because of poor technology. Because our people don't want to go into that field. Everybody wants to go to the office quickly and get a lot of money, and then go and enjoy your life. Now, this is called the fractional column or distillation column, yes? The distillation column, it looks simple here, but in real fact, it's like a two-story building, okay? Two-story building, you put crude oil, which is a liquid, or thick liquid, or vacuous liquid, thick one, which consists of hydrocarbons, okay? The simple ones are, but they are all jumbled together in a liquid form. So to separate it into more useful forms, like petrol, kerosene, they have to be distilled. So the crude oil, when it comes here in the big tank here, heat is applied, okay? When heat is applied, the crude oil, just like if you put water on in a kettle, it boils and boils, you see bubble going up in it, and then the steam going somewhere, yes? So same thing, if you heat a liquid, you see the steam. That steam is different hydrocarbon. They go through the column, okay, depending on their boiling point. Now, why different boiling points and why different fractions or different part of the crude oil separate into all the useful forms? Why that happens? I want to go back to our simple covalent bonding, okay, simple molecules, how they are forms. I explained here that hydrogen has one electron in its atomos cell. But for hydrogen, the atomos cell is the K cell. You know, we have the nucleus. Around the nucleus, we have the K cell, okay? And we have the L cell and the M cell. K cell can take only 2 electrons, and the L can take 8 maximum. I mean maximum 8, okay? Now, hydrogen with only 1 electron, okay, if it is going to form a bond with another hydrogen, it will do so by means of a covalent bond in it. By means of a covalent bond. Covalent mean what? Sharing of electrons. Sharing of electrons. Sharing. Instead of one hydrogen donating electron to this hydrogen, okay, forming this one having no electron in atom or cell, they form a covalent bond by sharing electrons. Now, if they share electrons, that means this hydrogen will provide that electron, this hydrogen will provide this electron, and they share it. Now it appears all of them, their K cell have 2 electrons, and now they are stable. Okay, they will not be in motion. Okay, looking for an electron to snag to become stable. Now all of them appear to have 2 electrons in their outermost shell, so they form a hydrogen molecule. A hydrogen molecule. This is a simple molecule, only 2 atoms in it. Okay, hydrogen molecule is a gas at room temperature. What's room temperature? How many degrees?
37.
Room temperature, they are all gases. Now this molecular format, we can represent in what we call in dot and cross. Dot and cross, we have the hydrogen, the atom, the electron of this hydrogen shared with the electron of this hydrogen. It is represented like that. So this is called dot and cross. Okay. Another way you can represent is hydrogen and hydrogen bond. Now we are going to do, when we do bond energy, we are going to look at this bond energy. When we do bond energy, we look at this hydrogen to hydrogen bond. Okay. Now this is a simple molecule. Now within this is a covalent bond. Within the electrostatic, okay, the electrostatic forces, put your camera there. Within the molecule, we call it intermolecular forces in it. It's strong. Okay? So covalent bond tend to have high boiling points. That is the general description of covalent bond. That's the general characteristic or general property of covalent bond. They have high melting and boiling point. Yes? That is understood. But if you have hydrogen in a container, basically you have like this: hydrogen, 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 hydrogen. You get me? Hydrogen, hydrogen. Now, but the bonding between the molecules, what do we call them?
Intermolecular forces.
We call them yes. The intermolecular forces is very weak. Just like water is like this. Okay? You have oxygen, then 2 hydrogen in it. But you have another molecule of water. Okay? That one also hydrogen and oxygen, yes? So basically it's like this. O, H, H. Now, within this, within the molecule is a covalent bond. But the forces between the molecules of water is very, very weak. That's why you apply very little amount of heat and the water turns into gas called steam. The same thing happens between the hydrogen and hydrogen molecules. That's why at room temperature they are gas. So if something is gas, you just have to put a match and it flames up in it. If you put water and you put match on top of water, do you flame? No. Okay, because this is highly volatile, very, very low boiling point. Okay, this is what we mean by simple molecules. Simple molecules, simple covalent molecules. Now let's look at another one. Let's look at a compound. Let's look at chlorine, okay? Chlorine gas. Why do you have chlorine like this? Cl2. Two atoms of chlorine form a covalent bond. Okay. How many atoms chlorine has at the atom cell? 7. Okay? 7. And 1 here. Another chlorine, let me do it with a different pen. Okay, that one has. We have done this before, so Cl, chlorine. Now I'm drawing only the outermost cell. I'm not drawing the innermost cell because chlorine is 17. 2, 8, 7 in it. Yes. Now the outermost cell, this chlorine and that chlorine, they will combine together by forming a covalent bond. Yes? Covalent bond. If that happens, it will look like this. One has its electron, another has brought its electron. This is Cl, this is Cl, and that's why you have Cl2. So chlorine to chlorine gas, a simple molecule as well, it will have one chlorine sharing electron with another chlorine in form of a covalent bond. So it is Cl2. Now if you draw the dot and the okay, same thing. Okay, this is called the dot and cross. That's how you do the dot and cross, yes? Cl, Cl. Okay? Now, this means they share these two electrons, and each of them appear to have 8 electrons in their outermost shell, and that is the stable shell configuration they're all looking for, to have 8 in the outermost shell. I mean, in this case is the K shell, isn't it? Or not the K shell. K is 2, L is 8, the rest is all 8, isn't it? The M shell, yes? So this is a simple chlorine covalent molecule. Simple chlorine molecule. We can do this thing for all the simple molecules. What we are trying to get is why they have different boiling and melting point. Yes? If we look at carbon, how many electrons do carbon have in the outermost shell? 4. It is 1 here, 1 here, 1 here. So that means how many covalent bonds can carbon form? 4. So carbon can form a covalent bond here, covalent bond here, covalent bond here, covalent bond here. Any compound with 1 electron in outermost, any atom which have 1 electron in atom can come here. We can have hydrogen which has 1 electron, hydrogen here, hydrogen here, hydrogen here. So that will be CH4. What do we call this compound? Methane. We did this under hydrocarbons, yes? Called methane. And this is also a gas in room temperature. All this is their gas. We can do nitrogen, okay? We can do iodine, we can do fluorine. All of them will have simple covalent bond, and the ones in the top of the group will always be a gas at room temperature, okay? A gas at room temperature. Now the reason why they separate is basically their boiling points. And that has to do with intermolecular forces, yes? Now, so basically, covalent compounds are made of simple molecules, okay? Now, those simple molecules, within the molecule itself, there are strong molecular forces, yes? But within the molecule itself, okay? Like, let's draw one of them, okay? Especially oxygen, yes? Oxygen, you have 2 oxygen molecules. We have not done oxygen, yes? But it will be 2 oxygen sharing electrons in it, in a covalent bond in it. Okay. Okay, and this will be O2, 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 O2. Okay? Let's say you have this oxygen. I'm not saying about this, about the crude, this you have in crude oil. But let's say you have this oxygen in crude oil. Now, you apply heat. And then they are with some other molecules, other compounds, yes? Now, between the oxygen molecules, within the molecule itself, we say there is strong intermolecular forces in it. But among themselves, that's what we are looking after, yes? Among themselves, the bonding is very, very weak. Yes? Because there is no scattered electron. What do you call? Delocalized electrons on the side. Yes. Yes, it is a covalent bond. Completely 8 electrons in the outermost shell, they're sharing it. There is no delocalized electrons, like in metals, yes? Now, that's why if you apply heat, these bonds, they break up. When they break up, they form a gas. In the liquid, they'll form a gas going up. So when they go up, let's say you have covered this place. You covered this place. You see, when you apply heat on the liquid on which the oxygen is, the intermolecular forces, they'll break up. But they'll break up with other compounds which have similar boiling points in it. Because they have similar forces between the molecules. So when they go up, they don't have anywhere to go. They'll fill the space here. But if you have an outlet here, what happens? The gas will escape in it. So when it escapes, you have another big tank here. They'll go inside the tank. Do you get me? Now, if you apply heat, some heat on that one also, if you have about, let's say you have 7 compounds, all of them cannot have the same boiling points. Do you get me? So therefore, they will separate based on their boiling points. So you have many, many tanks. That's what happened with the fractional distillation column. Okay? Fractional distillation column, when you apply heat here, you apply heat on the crude oil. And the crude oil, I say, is a very thick, viscous substance which they put in big barrels in it, big containers, yes? Now, if you put all your crude oil here, you apply heat. When you apply heat, what happens? The molecules or the inside that thing will gain heat and they'll start moving in it. Okay, so there's no space, they have to go through this space. When they go through this space, it's all pour here. The one with the lowest boiling point will stop here. Okay? Sorry, the ones with the highest boiling point, yes, will stop here, like the tar. It's called bitumen. Bitumen is tar. That's the thick black they use to surface roads, yes? That will drop here. See, it drop out here. The ones which are gaseous, they will go up. Okay? When they go up, they'll condense. The first one is heavy fuel oil. Now, if you look at the car, you put petrol in the car, or you put diesel. But there's a heavy oil you put to lubricate the engine, to make the engine a bit oily and so that it can function properly. That is called heavy fuel oil. Sticky one, yes. You see, they sell it in the container. Yes. Those ones have a very high melting point. They will also, when the liquid goes up or the gas goes up, because too much heat is applied, they will settle here. You understand? This is designed in a way that it cannot drop down. When the liquid or the gas goes up, it comes here because the temperature is a bit higher here. They will drop here. Okay? Then you go to diesel. The same gas steam goes up again. When you reach the boiling point of a diesel oil, those where diesel oil will drop there. Now, the compound that consists of diesel oil is not one compound. It's different type of hydrocarbons. It could be from, you come to that, from C10 to C15. All that will be hydrocarbons with a carbon of C10 up to C15 will be diesel oil. Do you get me? Now, we can say from C5 to C9, okay, will be kerosene in it. So petrol will be, let's say, C2 or C3 to C5, okay? Then the last of them is gas called methane, okay? And ethane and propane. These are gases, okay? They are not liquid. Petrol is liquid, kerosene is liquid, diesel oil is liquid, heavy oil is liquid. Because they have those boiling points. The ones which are gases, the temperature is less here. They will still go up with those liquids until when the temperature is about, let's say, 5 degrees centigrade, you'll see it from there, 5 degrees centigrade, then that will be gas. Okay, so this is called the fractional distillation, meaning the component of crude oil are separated based on the boiling point of the compound inside the crude oil. And so these are called fractions. The fractions of oil, fraction petrol, will be based on the number of carbons. Let me show exactly what is the chain of carbons that is petrol. Okay, now, so this book here says, it says that petrol, the boiling point is even less than water. What's the boiling point of water? 100 degrees, isn't it? Okay, petrol is about 80 to 70 degrees. Naphtha is about 80 to 190. Kerosene, 190 to 250. Diesel, 250 to 350. I mean the boiling point. Water is 100 degrees. 100 degrees, water will turn into gas. So that means petrol, just 30 degrees, 30 degrees, you can separate it from a liquid. A liquid has petrol inside it. If you boil it up 30 degrees, the petrol will go out. You get it? That is 1/3 the boiling point of water. Okay? Naphtha is another component of crude oil, very important. About 80 degrees, it will separate. Okay? Now, it is saying also that the hydrocarbons, yes, 4 hydrocarbons, we call it butane in it. Okay? That means a hydrocarbon with 4 carbons, we'll call it butane in it. 5, we'll call it pentane. 6, we'll call it 7, septane. 8, octane. 9, nonane. 10, decane. 20, 20 is called icosane. Icosane. 40 carbon is called tetracotane. Tetracotane. It's called tetracotane. Look, all these are inside the crude oil. Okay? All these are inside the crude oil. And they have different boiling points. So if crude oil, kerosene, petrol, if crude oil is supplied here and is heated, the different the steam goes through this. When it goes through this, the one with high boiling point, the one with very high boiling point will drop. Okay, so I just go on the different fraction, the different part of the crude oil will separate based on their boiling point in it. Okay, so they said diesel oil is used by cars. Okay, diesel, you heard of diesel in it. Okay, heavy cars. Kerosene is used by aeroplanes. Petrol is used by cars, and the petroleum gas or methane are used for cooking in it. Bunsen burner in it, cooking. Yes. So this is called fractional distillation. How many minutes do you have there? Read from this book. Fraction from crude oil can be processed to provide fuel for most modern transport. Diesel oil, petrol, kerosene, heavy fuel oil, and LPG. LPG is called liquefied petrol gases. Be careful, they can ask you about this. What is LPG? These are different type of gases that are liquefied. That means the temperature is reduced to turn them to liquid. If you want them in gas also, you heat it in it. Just like water. If you reduce the temperature of the water, what does it become? Ice in it. Become block. But the same ice, you put it on the table, it changes into liquid. Okay? That liquid you can boil it and kick it into steam. So the same thing applies here. Gas can be liquefied. That the temperature can be reduced so that they turn into liquid. Okay. And used for cars, trains, planes, and other forms of transport. The use of hydrocarbon depends on their properties. The volatility helps to decide what fraction is used for. Because the different volatility mean different boiling point. It's just a word, but it means different boiling point. Because kerosene, if you put it in the oven, you see the kerosene, you see the vapor of kerosene on top of the container. Okay? Because the temperature outside is higher. Okay? So therefore, it forms steam. If you put water on it won't happen. That won't happen unless you apply more heat up to 100 degrees centigrade. If you do that to kerosene or petrol, you will see the vapor of kerosene or petrol coming up. Because of the temperature, the boiling point is lower. Okay, that's what we call volatility. The LPG fraction, which is liquefied petrol gases, has the lowest boiling point. In fact, it is gas at room temperature. This makes it ideal for using as bottle gas. It is stored under pressure as liquid in bottles. When the tap on the bottle is open, the fuel vaporizes and flows to the burner where it ignites. The petrol fraction has a higher boiling point. Petrol is liquid at room temperature, which is ideal for storing in fuel tanks of a car, it can flow to engine where it easily vaporizes to mix with the air before it is ignited. The viscosity also helps decide how hydrocarbons are used. Really gloomy, viscous hydrocarbons are used for lubricating engine or covering rods. We have seen bitumen, yes? Now, the product you get from crude oil are examples of organic compounds. Okay? The reason you get such a large variety of products is because carbon atoms can bond together to form different forms of homologous series. Homologous series we come to know later. These groups contain similar compounds that all have the same general formula and many properties in common. Okay, like petrol. Here, we say it is about kerosene about C5 to C9 in it. Yeah. So C5 is pentane, C6 is hexane, C7 is septane, C8 is octane, C9 is yes. So they are homologous compound in it. Similar boiling point and similar properties in it. This group contains similar compounds that all have the same general formula, many properties in common. Alkanes, alkenes, as well as other families such as alcohols and carboxylic acids are all examples of homologous series. Okay, this is what we call fractional distillation. We have done cracking in the previous. Let me clean this. We have done cracking in the previous. Yes, cracking. What it means is you have hydrocarbons. Okay, C80, 172, or even C100, H222. Okay, you separate them by cutting the bonds in it to have C3, 8. Okay, C10, H22, C6. Okay, H14. I told you what is the formula to get hydrocarbon. Yes, is Cn, okay, H2n plus 2 in it. Yeah, that's what I'm applying. For every carbon, one carbon, you need that amount of hydrogen. I told you how to get that, yes. So basically, cracking is just splitting, okay? Splitting the long chain hydrocarbon into different components, yes? Yeah, so long molecules, like here you can have diesel, you have long molecules here, you separate into shorter ones, yes, depending on what you need. You need kerosene, you need petrol, you need diesel, okay? That's by cracking. And there are two types of cracking. Do you remember? What are they? Huh?
Thermal decomposition.
Yes, cracking is part of thermal decomposition, yes. But what type of cracking are there? We have catalytic. You guys forget so soon. Catalytic cracking and steam cracking, yes. Do you understand what this means?
Yeah.
Yes? What's catalytic cracking?
When they use a catalyst,
When you use a catalyst, what catalyst?
it's an iron.
Ferrous.
It's an iron that is used in the reaction.
Yes?
You find alternate pathways for the
Yeah, this is called ferric oxide, isn't it? Yes? This is called ferric. Leave it. This is called ferric oxide, isn't it? This one, steam is used in it. Yes? To heat it and then it divides into different components in it. So you have catalytic cracking, we have steam cracking. So you have to understand for fractional distillation and cracking and then the hydrocarbons, what form the hydrocarbon, what compound form the hydrocarbons. First the alkanes, then the alkenes. Yes? We have done the alkanes. To alkane we said we have a formula of Cn H2n plus 2 in it. And it depends on the number of carbon. The first one with one carbon is like this. It's called methane in it. Ali?
Yeah.
The second one with two carbon is called ethane. The third one with three carbon is called propane. Then it goes on like that. Four carbon is butane. It goes like that. 5 is called pentane. And then we have 6 carbon. It's called hexane. So it goes on like that. Okay, so you are supposed to know up to the names, at least up to 10, 12. 1, 2, 3, 4, 5, 6, 7. This is called septane. Septane. Okay, now we have octane 8. Octane 8. We have nonane 9. And you have decane. So you should know up to date. This means 10 carbon, 9 carbon, 8 carbon. Okay, these are called alkanes. Why are they called alkanes? Because they have one carbon to carbon bonding. Now when we look at alkenes, they have 2 carbon to carbon bonding. Now we are going to do, our next topic is the alkenes.
Have one double bond.
Yes, alkenes. Okay, remember they are E in it. This one is A. So this means, if you say E, it means one,
Double bond.
at least one double bond. So a carbon can have how many bonds? 4 covalent bonds. Yes, we said carbon have 1 electron here, 1 electron here. Mean it can form 4 covalent bonds. Yes, but if it has 2 bonds already, how many more covalent bonds you need? 2. So you can have only 1 here. That's why this one is called, who knows this? Ethene. Not methane, because methane means 1. Yeah, okay, 1 carbon. So double bond will need another carbon. So that's why the feature of a alkene is at least 1 carbon to carbon double bond. This is called ethene. Now we are going to look at alkenes. How different are they from alkanes? And their names end with, okay? Their names with in it. Yes. So ethene, the next one will be propene. And butene in it. And pentene. So you go on like that, like that, like that. These are very, very important compounds because they form, the butter you eat is from that. The margarine, the butter, maybe some of the oils is that. Yeah, alkenes in it. Yes. So there you are. You go and look at this. A good student, after you teaches you, you go and look at them. Get a textbook and read about them. Okay, that consolidate your understanding. Okay. Subhanallah bihamdi subhanallah alazim.